All right, hello everyone. So thank you for joining us today for this second webinar of qualification. Today we will address the question how to qualify a 96 to 384 well plate reformatting process. So first of all, let me introduce myself. My name is Valentin Bechio and I will be the moderator of this webinar, and I'm here with my colleague, Mr. Alexandre Perret, who will be the speaker during this webinar.
Hello, everyone.
Okay, so before we start, let me share with you a quick agenda. First, we'll start with a short introduction of Discngine, the application called Qualification and its concepts. Then we'll go over the use case presentation we chose for this live demo, and following by a live demo made by Alex using the application qualification. And at the end of the session, we'll have a short Q&A session where you can ask your questions. And before this starts, we'll have a short question for you. So please stay with us until the end. Okay, but before we start, let me introduce you to the tool we choose to perform this webinar. It's called GoToWebinar. And you should see a small control panel where you can ask your questions thanks to this section. And we will answer it at the end, or if we have too many questions, we'll answer you directly by email afterwards. Okay, so now I leave it to you, Alex, and I hope everybody will have fun.
Okay, thank you, Valentin. Again, thank you everyone for joining us for this webinar. So first, let me briefly introduce you the Discngine company. So I'm not sure that everyone have heard of us already, but so we are a company based in Paris, France. The company was founded in 2004 by two Pfizer alumni. We are now 46 employees and still growing. And basically what we are doing is that we provide services and solutions for life sciences research informatics. So we are more focusing in the early drug discovery process, but as you can see in the list of customers that we have, so this is a non-exhaustive list, you can see that we also work with some agrochemical company and biotechs. I think that you will recognize most of these companies. So today we are here to talk about Discngine Qualification. And the specific question that you would like to address with this application is, isn't it frustrating when the volume dispense is not the one you expected? So I'm sure that if you're doing liquid handling operations, you at some point ask yourself if you have the right volume in your wells, and based on the feedback we got from our attendance to several workshops, roundtables, and conference, well, we noticed that there were some existing tools for the calibration of mechanical pipettes, but nothing really for the automated liquid handling systems. So, well, you know that there are some kits available to calibrate the liquid handling process, but it's going to give you an evaluation at a given time. But there is really nothing on the market to track the performance of your liquid handling operations. And this is the main question we want to address with this tool. So we also had a couple other questions from our partners or customers and from people we could speak around the workshops we attended to. First, a lot of people would like to have an easy way to identify their drifts in their process. So can I easily identify my drift? Is my process robust over time? This is one question we're going to answer with Discngine Qualification. The other questions is, well, let's say that we are all working for in a lab for a company, obviously a green company these days. And in our lab, we have a lot of different devices. So we have balances, readers, liquid handlers, and these devices give us many different output files, different formats, and it's always we always struggle to centralize everything, to combine the information, to join the information from different formats. So to answer this, we wanted to have a collaborative platform for all the robotic equipments in the lab. To have an easy way to centralize and share the data and combine the data together. So now let me speak more about the concept of qualification. So to go more in details about it. So in the application, we have three levels of information. The first one is the one we call platform process. So in qualification, the platform process is a combination of three different information about the platform, the pipetting head, and the process. When you combine this information, you can name your platform process. The second level of information is the qualification. And when you have the platform process that you just defined before, you're going to add information about the volume distribution and the qualification materials. So the volume distribution will be actually what target volume you want to qualify, what is the distribution of your volume inside a plate or inside a set of plates. And the qualification materials will be how many plates will you use, what's the plate format, what the solvent, the liquid class, etc. The idea here is for the operator, for the scientist, to transpose everything he's doing on the bench into the application. So what we called, the concept we called qualification in the application is actually meant to represent your experimental protocol. So once you have defined this, you just need to take data coming from balances, readers, and upload them into the application and start working with this data. So here we name it colorimetry, but it's kind of a language abuse because you can also work with volume data and fluorescence data, so not just optical densities. So for today, if I take the use case I'm going to present you, and if I fill the box with the use case, so the platform will be the Agilent Bravo. The pipetting head is a 96 pipetting head from Agilent. The process is obviously the reformatting from a 96 to 384 well plates. So I call it, so this is my platform process, and I call it Bravo 96, etc. I'm going to use three different volumes, so 1, 2, and 5 microliters. Those are the volumes I want to qualify. And to do so, I will use 6 384 well plates and water as a solvent. I'm only going to use data coming from a reader, and in this particular use case, the data are coming from a Perkin Elmer ENvision absorbance reader. So to be a little bit more schematic and add some information, this is how the use case will happen. We will start by using a reference plate, because in my case, I fill the plate with a calibrated mechanical pipette. So I filled 5 columns of my plate with 5 different volumes, 1, 2, 4, 5, and 7 microliters. And I'm going to use this raw data to to do a fitting procedure to get some parameters to convert optical densities to volumes, because it's way more easier to speak in terms of volumes than optical densities. And then once I have my calibration curve, I will use the raw data coming from my Perkin Elmer ENvision and corresponding to the 6 plates I filled with my Bravo and with the 3 different volumes I want to qualify. All right, so let's go in the application. Okay. So this is the home page of the application. I'm going to put this in full screen. All right. So this is actually a pretty standard menu where you have the analysis part. It's where you're going to create your analysis. Qualification history and platform process history are sections where you will be able to track the performance of your pipetting operations with control charts. We have an event tracker section, which is basically a calendar where you're going to add events about your platforms or your pipetting heads, for example, preventive maintenance or any other events that could impact your platforms or your pipetting heads. And the last 2 sections are quite standard about team management and the administration. So sections for you to add members and to define any devices that you're using in your lab into the application. So let's start with the creation of my analysis. So for the purpose of this use case, I've already defined my qualification. So here is a menu of all my qualification, all my analysis, sorry. So obviously I'm working in a team and I have different for several colleagues and everyone can work on the same environment. Obviously I can see who created what, so it's allowing us to share and speak about the different qualification method that we're using for any specific use case we have in the lab. So let's go to the creation of an analysis. So like I said before, I've already defined my qualification, but I will show you more in details how it looks like. So you have the platform process name, the target plate format, and information about the pipetting head. So the name of the head, the format, the serial number, etc. And the information about the volumes. So here we are using a multiple volume use case. And we have layouts, control volume, and channel layouts since we're doing a reformatting process. So in my lab, the procedure for the qualification of my process is a monthly procedure. So every at the beginning of every month, I'm going to qualify all the process that I'm using, the liquid handling process that I'm using in the lab. So today we're in February, so I'm going to qualify my reformatting process for this month. All right, I'm going to use colorimetry data, and the essay was done in the 5th. So let's say that today we are the 5th of February. And you can see that there is actually one event attached to the device, attached to the platforms. And this event says that there is something wrong with my pipetting head on my platforms, and I say to the user, please do not use the liquid handler. So I'm in charge of my of the QA/QC operations in my lab, and now I want to make sure today that everything is back to normal. So I go to the next step, which is already defined when I created my qualification. This is where I define my layouts, so control, volume, and channel layouts. So I'm going to quickly show you how it looks, but here we're going to use samples in every well of the plate. And we have a volume layout of 1 microliter. So since we're working with 3 different volumes, we'll see in a later step that we can change the layouts. And since we are doing a reformatting process, I set my channel layout to 96 different channels. So it looks like this. So I have here all my channel, 96, and I can see I defined actually in each well each channel will dispense. So it's pretty easy. You're going to say or think probably that manually enter 96 channel is kind of a pain, and I completely agree with you. That's why we have this quick filling operation where you can choose to fill automatically your layout with the number that you want. So here in 2 clicks, I have my 96 channel layout here. Okay, so now I'm just going to upload my raw data file. So this is my files, my data from February. So I select them all and I upload them all at once and go to the next step. So the next step will allow me to change the volume layouts. So here I have my 6 plates, and I know that the first 2 plates, there is 1 microliter in my plates, but the 2 next ones are 2 microliters. And the 2 last ones, 5 microliters. Oh, forgot this one here. So I do it manually, but if you have several plates, like dozens of plates, you can use the checkboxes here and apply automatically a layout that you pick. So like I said before in the presentation of the use case, at first I filled a reference plate with 5 different volumes. So I'm going to use this reference plate to define a fitting procedure. So my volume unit is microliter. The conversion procedure is linear regression, but I can also choose polynomial regression if I want to. And here, if I already have the regression parameters, I can enter them manually, or I can set my calibration from raw data. So since I'm doing my qualification process for February, that means that I've already done it for January. And in January, I already used a reference plate. So here I have a choice. I can either use the calibration parameters defined in the first qualification of the year, so in January, or that's what I'm going to do. I can create a new calibration. So here I'm going to define my control layout. So since I'm only using five different columns, so you can see that I have my first 5 columns filled with sample and the rest is empty. And my volumes are 1, 2, 4, 5, and 7 microliters. So I'm selecting my reference plate here, and then going to the next step, where I will have the result of my fitting procedure. So you have a section for the calibration details about the different layouts and the regression procedure that you use. You have information about the calibration data. So for each volume corresponding to 1 column in your plate, you have the average, standard deviation, and the CV. And finally, you have your fitting results here, where you get the value, the R2 value, and most important, the two parameters A and B that you will use to convert optical densities to volume. So you have a look at the regression curves. It looked pretty good to me, so I'm going to apply this procedure. So the calibration parameters are applied to my raw data, and I'm going to the next step, which is a validation step. And this is where I will start to have a look really to my data. I will get first the volume distribution in my plates. So you have here a plate viewer. So this is my first plate. You have the volume range. So here the volume comes from your conversion procedure that you just defined earlier. And the first thing that you can notice is that in my first plate here, well, I have some kind of a volume gradient. So it looks like my wells are filled with more volumes in the bottom left of the plate, whereas the top right of the plate show less volume. So you can filter here by target volumes. You can filter by plate, and you have different tabs allowing you to look at your data from different standpoints. And the first tab where I will go is the Quadrant one, because I'm in a reformatting process, and I want to have a first information about the behavior of my pipetting head. So the first information I have is the volume average and the volume and the CV for each quadrant, always corresponding to a specific target volume. So in this case, with the 1 microliter, that means that I'm taking under consideration the plate 1 and 2. So I can see here the value of the volume average for my first quadrant for the 2 plates. I also have a plate viewer where it represents the pipetting head format, and you can see actually the same pattern that you just saw in the well tab, so about this volume gradient. And you have information about the volume average here and about the relative error. So in qualification, what I have is actually information, different information about my data, and that's up to me to take some decision according to these to the information I have. So let's go next to the plate tab. So here I will have information on each plate, information about, again, volume average and CV. So volume average will be related to the accuracy, and CV is the precision. And for the first plate, I have a volume average of 0.95, and I can also have this information for the second plate, etc. Finally, what I want to know is if there are some channels in my pipetting head that have that has a wrong behavior. So I have the channels tab that can help me with that, and it will show me the performance of each channel individually. So as for the last the tabs before, I have information about volume average and relative error. And the first thing I can see is that there is a pattern here. Actually, we can see that there is a pattern of 12 channels. So this is the first 12, and then I have 13 to 24 to the 24th, etc. And the channel is, the pattern, sorry, is composed with 8 different sections. So it means that I say that it represents the 8 lines of my pipetting head. and you can see with the relative error, you can definitely notice that you have this particular pattern ongoing. So it kind of gives you let's say that it comforts you in the observation that you may had in the well and in the Quadrant tab, but now you can see it from a channel standpoint. So that was the validation step. So I'm the operator, and I validate my data. And now I want to go to a next step, which is the summary step, and then I will have a global overview of the accuracy and the precision on my reformatting process. So when I created my qualification, I've defined some acceptance threshold that I can change here, threshold about the accuracy and the precision. And these thresholds are used here to give me quickly information if I'm in range or if I'm out of range. So it's all green boxes here. So it says to me that okay, everything is good, everything is in range for this process. So now I will publish the data. So publishing the data in qualification means that I will add the data to a history. So that I can be able to compare this data with previous analysis. In my case, with the analysis of January. So I'm going to publish this and go to the qualification history section, and you will see that. Okay, did I click? Yes. You will see that I actually have 3 analyses here, because when I've done my analysis in January, so this is the first one here, actually for the accuracy, everything was out of range. So even if the precision here was quite okay, the accuracy was really hard. So I just add an event about my platform and my pitting head, saying to my colleagues and to the operators or the scientists that will work on the liquid handler, to warn them that they have to be careful. So they may be still able to work with the liquid handler, but they have to be careful with the data they can have, they will get, because somehow the accuracy is for the reformatting process is quite is odd, is out of range. So to make sure that things don't get worse, I decide to 2 weeks after my January analysis to have a new analysis just to check if everything was okay. And when I ran this this analysis, well, I noticed that the CV was completely off the chart. So here I had to make a decision, and I just created a failure maintenance. I called the maintenance person at Agilent in this case, and I said to my colleagues, scientists, please do not use the Agilent Bravo anymore, because there is definitely something wrong with it. So my maintenance operator came, he worked on the platform and the pipetting head, and then I wanted to check, so at the beginning of February, if everything was back to normal. And this is my third analysis here, and I can see that fortunately it's okay again. So that's actually what I wanted to show you here in the application, and now that I'm sure that everything went back to normal. Well, I will do the standard procedure in my lab, meaning that every month I will again have my qualification process, so a new analysis that I can create in the application, add the information in this history and compare this the performance of my process. So this is basically how the application works. So if I go back to my slide deck, yep. So what you just saw here is that you can easily integrate calibration curves. So the feedback we had so far was that it was only possible to do it within Excel. So now that you don't have to use it anymore, you can do everything in qualification. You can obviously have a look at the performance of your pipetting head. So using in our case the quadrant tab, we have a look about the behavior of the head. And with the control charts, we can track the accuracy and the precision of the process. And since we are working as a team, well, I can easily share my QA/QC operations with my colleagues because, well, I'm in charge of the Agilent Bravo and other platforms, but I may have another colleague in charge of the Echo or any maybe other liquid handlers. As for the business benefits, well, I think that you will all agree with me when I say that overall it can help the QA/QC team and all the scientists actually in a lab. It can help them manage their materials, so prevent to or avoid to throw away some plates because the performance were not right. And so basically here qualification allows you to make sure that over the year that you have a well working liquid handling process. So that's about it for me, and I will give the hand to Valentin.
All right. Thank you, Alex, for this very qualitative presentation. So yes, before going to the feedback and questions session, we first have a few questions for you. And you will be able to see it on your screen, and you can answer directly on your screen. So the first one is, after what you just saw, would you like to be contacted by a qualification team member after the webinar? We can explore together your different use case and explore how Discngine Qualification can help you in your activities. So I just left a few time for the different participants to answer. Okay, I think we have almost all the answer. All right, another few seconds. Okay, all right, I collected the answer, and we have another one for you, which will be more related to you. So it will be, what would you like to see for the next webinar of Discngine Qualification? So we have a few subjects we can address. You can see a webinar on serial dilution use case, another one on a new reporting feature we are currently developing for you. Or if you want, we can address another use case that you can send us. And last one could be surprise me, and we can do something for you and find a new subject for you. So like the previous one, I'm waiting for every participant to vote. So yeah, we can wait a few seconds more. Okay. So we got a lot of answers. That could be great. Okay, so next we are moving forward with our feedback and question section. So the first question that was asked, by one of you is, can I use any plate format for the calibration procedure? So Alex, maybe you can answer that.
Yes, thank you for the question. And so actually, in the application, you can indeed use any kind of plate format for your analysis. However, when you create a calibration procedure, you will have to use the same format that the one in the analysis that you're doing.
Okay, cool. Thank you for the answer. Okay, the second one is, do you have visualizations focused on the channel history?
So this is actually a pretty good question, because today, well, as you saw it, we can evaluate for a specific analysis the performance of each channel individually, but we cannot yet compare it with previous analysis. So we don't have yet the channel history, but this is definitely something that we have in the roadmap and that we are working on it. So it will be available in future releases.
Okay, thank you, Alex. And we have a last question, yeah, I will ask it for you. Is the application compatible with all devices, such as valve or pump mechanisms?
Yes, definitely. You can actually use the qualification application to qualify any liquid handling process coming from any kind of dispensing tool. So you can use the Certus, for example. So you can qualify the Certus that has eight valves, I think. But you can also qualify nanoliter liquid handler, such as the Eco from LabSite, and you can even use the application with your mechanical pipettes. So if you have a multi-channel pipette, well, you can define the channel layout corresponding to the number of channels you have in your mechanical pipettes, and do the exact same thing I've just shown you in this demo.
All right, so thank you, Alex, for this really precise answer. We don't have any more question right now, but if maybe you have a new one, feel free to ask us at the mail address you can see on the screen, qualification@discngine.com. And if you want more information about qualification and where we may be at some events in the future and anything, you can visit our website on qualification.discengine.com. So yeah, we can move forward. It has been a real pleasure to be here for you, and we'll be happy to see you next time. It was a little bit shorter than we expected, but it was a very qualitative presentation from Alex. And all right, so we see you very soon.
Thank you everyone for joining us, and see you at our next webinar.